for today's problem of the day on GFG, which is game of XOR. So let's read the question. The question says is you are given an array, integer array ARR. The value of the value of a subarray is defined by the bitwise XOR of all the elements in that subarray. The task is to compute the bitwise XOR of all the values of all the possible subarrays of ARR. Let me explain the question by using this test case 1, 2, 3. So what the question says is that this 1, 2, 3, what are the all the possible subarrays in this? So first, let's write down all these subarrays that are starting from 1. Okay, one sec. Okay, my bad. So these are all the subarrays starting from 1. So that would be 1, 1, 2, 1, 2, 3. Right? This subarray, and this subarray. Then similarly, let's write down all the subarrays starting from 2. That is 2, 2, 3. Makes sense? Then all the subarrays starting from 3. That is just 3. Okay. Now, the value of each subarray is given by the bitwise OR of all the elements in that subarray. So that would be here 1. This would be 1 XOR 2, that is 3. This would be 1 XOR 2, XOR 3, that is 0. This would be 2, 2 XOR 3, and 3. Now, what our final answer or the value of the array is basically the XOR of all the values of its subarray. So that here would be 1 XOR 3, XOR 0, XOR 2, XOR 1, XOR 3. So we can see here 1, so 1 and 3 gets cancelled out, so the answer becomes 2. Now, obviously, the first approach that would come to your mind is just brute force this. How can you brute force this? Like, let's go over all the subarrays and then we'll maintain the XOR of the subarray, and then we'll add it to the our final answer. So we can see here that I've coded this out. So x is basically the final answer, and then we'll just go over all the subarrays. We'll calculate the XOR of that subarray and then add it to Rx. But what would be the problem here? This is an O of n square solution, right? The number of sub square, the number, even we can say theta of n square, because this loop will run always n square. Okay, why is this erasing this? I don't know. Okay, so we'll write it here, theta of n square basically, and n here is given as, we can see, 1e5, 10 is to power 5. Yeah, so if n is 10 is to the power 5, this would do 10 square or 10 n square or 10 is to power 10 computation, which would obviously TLE. The maximum number of computation you can do is around 10 is to power 8 to 10 is to power 9, around this. So this is much bigger than this. So this would TLE. Okay. If this would TLE, how can we optimize it? Optimize it. Okay. My writing just does not want to be good. How can we do this? Let's think. In XOR, see, this element, what would be the XOR of this array? So the XOR or the final subarray. So that this would be 1 XOR 1 XOR 1. Let's say some k1 times, right? So and then 2 XOR 2 XOR 2 some k2 times. 3 XOR 3 some k3 times. Okay, right. So basically, because see here, what is if we break this down like to this only the final answer, it is nothing but 1 XOR 1 XOR 2 XOR 1 XOR 2 XOR 3, right? All the subarrays will only contain these elements. So I'm just saying, let's generalize it and we'll just say that the final XOR is 1 some k1 times, 1 XOR 2 some k2 times, and 3 some k3 times, right? Now, does it matter what is K1 exactly? What is K2 exactly? What is K3 exactly? What I mean by this is, like, if K1 is, let's say, 10, or K2 is or K1 is 4, what would be our 1? So that what is this is just 1 some 4 times, right? If 1 is 4 times, then all the ones would cancel out because x or x is 0, right? If x is 0, so 1 is occurring here even times. If it is occurring even times, then all will cancel out. So k1, so 10 and 4 will give a same XOR of 0. That is, if k1 mod 2 is even, basically k1 is even, then we do not add this ARRI. Do not add ARRI, else we'll add it. Else x equals to x or ARRI. Because let's take the example of k2, that is the frequency of 2 in the final XOR. So yeah, k2, let's take it as 5. So 5 is like this, 2 XOR 2 2, XOR 2, XOR 2, XOR 2. So this will cancel out this will cancel out 2. So you will be finally left with 1, 2. So else we'll add it one time, right? Now the exact frequency again we saw that it doesn't matter, only if it is it even or is it odd. So that matters. Okay. So now our question reduced to finding this K1, K2, K3. Okay. That is basically the frequency of the first element in the final XOR, the frequency of the second element in the final XOR, frequency of the third element in the final XOR. Okay. How can we do this? It's simple. If you have never done it, it might take you a second to get this example, to get to this frequency wala thing in the subarray, right? But if you have done this before, it's a uh, pretty simple answer that you can remember also. So yeah. The thing is that let's take let's take this example, right? So 1, 2, 5, 4, 3. Okay. So I want to basically get it how many times one occurs in all the subarrays, right? So like what are all the subarrays? So there would be some subarrays starting from 1. So that would be 1, 1, right? There would be some subarrays starting from, okay. There would be some subarrays starting from 1. There would be some subarrays starting from 2, right? There would be some subarrays starting from 5. I want to basically get us how many times does 1 occur in any of these subarrays. So for 1 to occur in any of the subarrays, the starting of my subarray has to be before 1, right? So starting has to be in this part, and the ending would have to be in this part, right? So my starting basic, or rather my starting has to be like this and my ending has to be after this, right? So how many choices do I have in my starting? I have one choice only. That my array could only start from this index. My subarray could only start from this index. So I have one choice in the starting index for 1 to be in the subarray, or the first element to be in the subarray, and my ending has n minus 1 choice. I can end here, I can end here, I can end here, I can end here. My subarray would have one, right? Now let's do this for 2. So for 2, my starting could be this point. Also, starting could be this point. My ending has to be after 2 of the subarray. So this is 2, this is n. This would be n. Okay, sorry. So a bit confusion here. So my starting and ending, the thing is that my starting and ending could actually overlap. So for first test case, this would be that the starting could have one choice and the ending has n choices, because my see starting has to be this point and ending could be this point also. So that is this subarray, this also has one, and then the ending could be this point also, ending could be this point also, ending could be this point also, right? So for this element occurs basically n times. Now for 2, as we were doing it for 2, so for 2 the starting point has to be either this point or it has to be either this point. So you have two choices. For the ending could be either of these points, 1, 2, 3, 4. So it could be 4 points. So that is 2 into 4. This occurs 8 times, right? Or yeah. Similarly, we can do for this would be 3 into 3. So basically, what the final basically ki, or basically the frequency of the ith element in all the subarray is basically I plus 1. That is all the elements that occurs before including it, and it would be n minus. So n minus I is, yeah, correct, n minus I. So that is this thing only, right? So if you can get this ki, then you can see if this ki is even, do not add arri. If it is odd, add it to the arri. So yeah, let's jump to the code. One thing that we can simplify, I am maintaining this ln and then doing this l plus plus r minus minus. We can just directly do ll count equals to uh, I plus 1 into, and we'll also make this ll I plus 1 into n minus I. Let's submit this and let's see if this works. Okay, this works. Let's submit it. Yeah, so I simplified it even further. So let's jump to the code. Basically, what we are doing is I'm going over all the I'm calculating n is arr dot site. Then I go over all the I maintain this x. This x is basically the XOR of all the sub-arrays. Then see, what we how we calculated this count. It's I plus 1 into n minus I, right? I calculate this count. This is count of basically how many times this ith element will occur in all the sub-arrays. If count is odd, then we'll add it to our array and finally return this x. Pretty simple solution, but to get it, it's a bit tricky if you have never seen like calculated how many times each element occurs in all the sub-arrays. So yeah, this is it from my end. Thank you for watching. If you like this video, subscribe, like all of those things. Bye bye.